Ladies and gentlemen, hello and welcome, coming to you not quite live from One Take Studios, where I'd like to talk to you about relations and functions today. This is designed to be very much an introductory video, so we're not going to do something super complicated, but this is an important foundation to get in place. Alright, so we're going to start with talking about relations specifically as being pairs of numbers. So if you're looking for how to attach your brain to this meaning, if you think of a relationship between two people, there we go, pairs of numbers. Maybe that'll help your brain remember it. How can I possibly, in the world of mathematics, write pairs of numbers? What could that look like? How can I express my relations? Well, I can use a set notation, there's tables, there's graphs, there's mapping, and I'd like to take a look at all four of those forms today. You could potentially also say an equation, but we're not going to go there right now. This is just a basic introduction. Alright, so I'm going to pull up some graph paper here so that we can get a better look at this. I've given us the start of all four of those formats that were just mentioned. So with this, I started with the table, probably because the table is one of the easier things to read with this. So if we're looking at this thing, I'm going to slide up, there we go. Okay, so if we are looking at this thing, it's been a day, I tell you. Alright, we can see pairs of numbers here. 1 and 2 are paired together. 4 and -1 are paired together. 3 and 2. -2 and 0. We have a bunch of pairs here. This is considered to be a relation, and this here is what is called a table. So this is one way to write our relations, is to put them in a table format, an XY table. This then hopefully you recognize as being a graph, and this is another way to write these. And so how do I get these on here? Well, again, I've got X and Y, and so this is my X-axis, and this is my Y-axis, and I go where it tells me to go. So on the X-axis, I'm going to go to 1, and then the Y is 2, so up to that is one of my pairs. So that point represents that pair. For -1. 1, 2, 3, 4 over on the X, and -1, Y down 1, so this point right here, that's another one. 3, 2, 1, 2, 3, 1, 2, there we go, and -2, 0, -2, and then 0, we're not going to go up or down, so that is it right there. So ladies and gentlemen, I had 4 pairs over here, and now I have 4 dots, 4 points on my graph. And so that is another way to express relations. I can see the pairs based on the graph using the X and the Y axis. I've used those same numbers over here, and we are talking about, if you look at, I put these in order, so -2 is the smallest number, followed by 1, and then 3, and then 4, but these numbers are the same as you're seeing in the X column. And these numbers are the same as what you're seeing in the Y column. Again, I put them in order, smallest one first, and climbing from there. This is what you would refer to as a mapping. And with a mapping, the idea is to kind of show a connection through arrows. So if we've got this, I'm going to say that these are my X's, and these are my Y's. I might use different words, fun and exciting words like this is my domain. So the X values are considered to be the domain, and this is my range. So you might see those words around as well, domain and range, X and Y. And this says that 1 goes with 2. So how do I show that? Here's 1, here's 2. 1 goes to 2. And I put an arrow to say 1 and 2 are paired together. 4 goes to -1. Here's 4, there's -1. Right there, that arrow connects those two. 3, 2. So 3 also goes to 2. That's going to be right over there. Again, arrow to connect those. And then -2 goes with 0. -2 goes with 0. There's my arrow to connect those. So we're going from the X to the Y, and the arrows show the connections. So, excuse me. We can show tables, we can show graphs, we can show mappings. This is the very start of set notation. This is the one that people usually don't like to write a whole lot, and it's harder to see the relationship than some of these other forms. But if I want to write this in terms of ordered pairs, it is a set of ordered pairs. So the funny little squiggle I've got going on here, that's the beginning of set notation. That's how we start off a set of numbers. Within the set of numbers, I'm going to have ordered pairs. So 1, 2. 1, 2, in parentheses. That is one of my pairings in this set. Comma, separating. Next set was 4, -1, so 4, -1, close parentheses. So there's 2 ordered pairs in my set. We always put the X first and then the Y, so 3, 2, 3, 2, there's another pair, and then one last pair, -2, 0. And because those are all 4 pairs in my set, there's the opening of the set, and we're going to do a matching one on the other side, closing of the set. If you struggle to make that simple, turn your paper sideways and draw a seagull and see what happens. It'll be close. All right. So I'm going to come back to this in a moment. These are all of our different formats. Okay, and then, so we talked about all these guys. What about functions then? What are functions? So everything here has been talking about relations up to this point. Let's look at our definition for a function. A function is, look at the first 2 words, a relation. So there is a reason we started with relations, is because that is the foundation for functions. So all functions are relations. All functions are pairs of numbers. So what's the difference? Well, there's a very specific condition that's been assigned to these pairs. It can't just be any old pairs. For a function, every x is assigned to one unique y value. Every single x is paired up with one y value and one y value only. This is huge, and this is one of the few things that sadly you really do need to memorize in the world of math. It's not something that you can necessarily logic your way through. This is the definition. This is where it begins. And this is one of the first things that's going to float out of your head as soon as this video is done. So you have to do a little bit of work to get this one in your brain and keep it there. But this is major, all right? A function is a relation in which every x is assigned to one unique y value. All right, so what could that then possibly look like? Well, what about what we had going on here? We just were doing relations. Maybe this relation is a function. What do you think? Here's my definition, right here. Boom, there we go, my definition. And here's all of my stuff. So these are all the same relation, but just different pictures, different formats. Could these be a function? Okay, well, here's an x value, it's 1. What is the 1 assigned to? The 1 is assigned to a 2. Is the 1 assigned to anything besides a 2? Nope, just the 2. That's unique. Awesome. 4 is assigned to -1. Is 4 assigned to anything else? Nope, just the -1. That's unique. 3 is assigned to 2, but nothing else. -2 is assigned to 0, but nothing else. This is a function. If you look here, -2 only has one arrow going out of it. It's got one assignment, one assignment, one assignment, one assignment. Every one of these x's is assigned to one y value. This is a function. All right, so I'm going to write right here in the middle of the page, function. So if this represents a function, and this shows us that every x has one unique y value, what does something that is not a function look like? Okay, I made you a separate set of numbers. Let me slide this. There we go, there we go, there we go. Let's check this puppy out. I left off our set notation. I'm going to go with these 3 because it's probably easiest to see with these 3. I made us another set of numbers. Okay, this is still a relation. These are both relations. This one we've set as a function. If this I'm trying to set up as an opposite example, why is this one, do you think, not a function? What is the 0 assigned to? The 4. And nothing else. What is the 1 assigned to? The 2. Oh, but wait. The 1 is also assigned to the -1. And we said that every x has to have one unique y value, but this 1 is assigned to 2, but 1 is also assigned to -1. That's problematic, all right? So because of what we are seeing right here in this section, this is our warning sign that this is not going to be a function. The 2's fine. It's assigned to the 3 and nothing else. But here I've got the 1 assigned to 2 different y values. So that's an indication that it's not a function. Let's jump over here for a second. What does that look like in terms of my mappings? 0 is assigned to 4. Okay, so 0 goes down to 4. There we go. There's my arrow for that one. 1 is assigned to 2, so 1 is assigned to 2, but 1 is also assigned to -1. All right, let me throw this last one in there. 2 is being assigned to 3. Great, okay. Look at the comparison between this guy and this guy. There's one arrow coming out of the negative 2 because negative 2 is assigned to one value. One arrow coming out of this. One arrow, one arrow. If I look at what was causing the problems over here, I can see the same thing causing the problems over here. 1 is being assigned to the negative 1, but 1 is also being assigned to the 2. This 1, this is problematic because it has 2 arrows coming out of it. It has more than one assignment instead of my one unique value. So it's another way that I can see that this data set, yes, it's a relation, but it's not a function. All right, so we are saying that this set is definitely not a function, definitely not a function. So we can see it here in the ordered pairs in the table. We can see it in the mapping because of the arrows. What do you think not a function looks like on a graph? Well, let's get these pairs in place and take a peek. 0, 4, that's the x-axis, that's the y-axis. So 0 and 4, 1, 2, 3, 4 is there. Okay. Oh, by the way, I can throw my x and my y over here, domain and range. 1, 2, that's there. And 1, negative 1 is there. So both of these go over 1, but here it says we go up 2, and here it says we go down 1. So this guy and this guy. And then 2, 3. 2, 3 is going to be right there. So think about what are our offensive points here. What is causing this to not be a function? It's the 1. Look on my graph where it says 1. Here's 1, and here's 2 different assignments. It goes up to 2, but it also goes down to negative 1. So at 1, I've got 2 different values, just like here at 1, I have 2 different values. This is what would be called the vertical line test. Vertical line test. If I've got an x value with more than one y value assigned to it, and I graph, those 2 points end up being directly over top of each other. And that is an indication that it's not a function. So if I can draw a vertical line and hit more than one point, it's not a function. If I can draw a vertical line and hit more than one point, comma, it is not a function. All right, vertical line test slide, there we go, get a good picture of that. If I can draw a vertical line and hit more than one point, it's not a function. And right now, if I draw this vertical line, vertical means up and down, straight through here, boom, 1 hit, boom, 2 hits, there we go, that's problematic. All right, so this is our vertical line test. If we use that vertical line test up here, think about this. If I draw a vertical line here, how many points will I hit? 1. What if I draw a vertical line here? 1, 1, 1. There's no place that I can put a vertical line in this graph and hit more than one point. So again, that means that it is going to be a function versus not a function. All right, so there's kind of a lot to soak up with this and a lot of different formats, maybe some scary looking stuff here, but this right here, get this one into your brain, and if you get this into your brain, everything else can kind of flow from there. Okay? All right, have fun.